All right, folks, welcome. Mr. Fortin here, one of your first proofs of the year for homework. And I got some questions about this, but this was an opportunity for you to learn with your group afterwards and maybe learn even after the class by watching this video. So don't worry about this one too much. What we say about proofs is the only way to get better at writing proofs is to write a lot of them. So if it doesn't happen in chapter one for you, you feel like you still don't really quite get it, that's okay. It might happen in chapter two. If it doesn't happen in chapter two, right, you're still feeling you're struggling with it a bit, then chapter three is a really good chapter because we'll have a lot more reasons and rules and a lot more practice with it in chapter three. And that's usually when people kind of get it. Anyways, looking at this one here, we can kind of keep in mind some of the things you could be doing right now to make your life a little bit easier on this one. One thing I want to call out is that it says copy everything shown and write a two-column proof. So always write out your givens, write your givens, and write your proof statement here. So you're just organized, because as you're writing it out, you're going to realize maybe some things I'm potentially talking about. For instance, as soon as you start writing midpoint, you might think, well, I'm going to use the midpoint theorem at some point. What can I say about the midpoint theorem? Ooh, LK equals GH. What is that? That's the whole equals the whole here. And then finally, I got to get a part to equal the part. MK equals NH. So just by writing it out, you're kind of thinking about what it is you're going to prove here, and also drawing of the diagram. Super important to draw the diagram, because then you see it and you can mark it up on your own pieces of paper. So let's check it out here. M is the midpoint of LK. So I know that this is a midpoint, and I know that N is the midpoint of GH, so I can mark those down. So I could say like LM is equal to MK and JN is equal to NH, because that's what a midpoint does. It creates two congruent segments. That's definition of a midpoint. My guess is here, because this actual this section introduced the midpoint theorem to you, that's probably what they're going to have you use. So if you think back, what was the big thing in this section? I'm probably going to use that. You're probably going to use the midpoint theorem in this one. Okay, so we have a couple midpoints, but then we also have this given premise right here that LK equals GH. That one's pretty important. So let's mark that down here. LK, tick mark here, congruent to LH here, or their lengths are equal as sort of written here. All right, what is it that we need to prove? And that's going to be this right here. What we're going to get to in gold is this information. So what I need to show is, well, this part of the whole LK, this here, is it congruent? Oops, two tick marks there. Is it congruent to this part NH of the whole? So this part of the whole, is it these two parts congruent to one another? So we know that the wholes are congruent. The whole segments are congruent, the larger segments are congruent. We know we have midpoints of both of them that are creating MK and creating NK. So can we deduce that MK has to be equal to NH? Well, let's check it out here, because I think we can get there following kind of our discipline here of writing out our givens, of course. So M is the midpoint. You can just scribble it out here. It feels kind of redundant to do, but it is important that you're presenting this as your original if statement, right? Because if M is the midpoint of LK and N is the midpoint of GH, and that's by given. And we also know that LK equals GH, then that's going to get us to a few things. First of all, well, we can say then, now that we have M is the midpoint of LK and N is the midpoint of segment GH as a given premise, I can kind of start talking about MK and NH, because I can ask myself, how does MK relate to, right, this part right here? How does MK relate to LK? Because LK is written right here. Let's come up with a statement that relates MK to LK. What would I have to do to MK, the distance MK here, to make it equal to distance LK? Remember, this is a midpoint right here. So I'd have to take MK and I'd have to double it. I'd have to do 2 times by MK would equal length LK. And I know that because there's a midpoint going on here. And what the midpoint is a proven theorem showing us is that we can state that one of the parts created by the midpoint, if we double the length, that would be the same thing as if we just had the length of the whole thing. So that's the midpoint theorem. So I can do this for MK. I can also do this for NH. So by the second step, I'm already thinking about what I need to get into the proof to actually prove it. And I need to get MK in, I need to get NH in. So I'll do 2 times NH, and that's going to equal GH. And that's by the midpoint theorem. And this is good because now I got MK and I got NH. I need to set up an equation where MK is on the left side, NH is on the right side. Or they could be on either side, because remember, equalities has the symmetric property. So what I can do here is I can look at my steps. How can I change some equations right here? I have LK here, that's equal to GH. Great. I have LK here, I have GH right there. So what I can do, because I have LK right here, I have LK right here, I can take 2MK and I can replace LK with it. I can replace LK with it. What's the reason for that? What's the reason for that? Well, it's not transitive, it's substitution. We're taking something that LK is equal to and substituting into this equation here. Look, we have LK is equal to GH, 2MK is equal to LK. So those are 4 individual statements being made here in these 2 equations. So this is going to be substitution. We're going to substitute 2MK in for LK to this top equation here. And then what we can do is do the same thing for GH. Because if you notice here, GH is what equals LK. And we can take this, because GH also equals 2NH, we can take it, pop it in right there, pop, pop, and we get 2NH. That was for you community fans out there. And the reason for that is substitution property of equality. Right? We take equal things, pop them into another equation, the expressions that they're equal to, pop into another equation, and we're good to go with a new equation. And look at this. We are super close to finishing this proof because we have 2MK is equal to 2NH in step 3. What do we have to do to both sides? So that's when you're doing a property of equality, as opposed to some of the other properties is when you're changing an equation, changing both sides of an equation by a certain amount. Either you're subtracting the same things from the same amounts from both sides of an equation, you're multiplying both sides of the equation by the same amount, or you're, in this case, dividing both sides of an equation by the same amount. So we're dividing this step by 2 both sides, and now this is going to simplify down to what our goal was, that proving once and for all that MK, this part here, MK, has got to be an equal length to this part here, NH, NH's length. Because, right, the LK, the holes equal to each other, and we had a midpoint, the parts will also equal each other. And this is the division property of equality. And now we have that proven. We have this as a fact right here. So given our original premises that we have, M being the midpoint of segment LK, N being this midpoint of GH, and LK, the holes equaling each other, we can deduce, and we have deduced, that the parts must be equal to one another right away by everything in between. So if given this as an opening premise, we've done the work. We've massaged this. We've introduced things that we know have to be true because we have a theorem, we have a substitution property of equality, and we've gotten down to proving our intended result, which is that MK has to equal NH. There's question number 29. Again, you get a lot more practice with it. The first few chapters. The proofs in chapter 3 are actually like kind of pretty fun, I think. You know, it's pretty tough right now, to be honest, because you guys can't really do that much yet. At the end of chapter 1, you should feel like you know how to do something, right? You shouldn't feel like you know how to do a bunch, but should feel like you know how to do something. So thank you for watching. Keep asking the questions, keep them coming in. Keep limiting all your problems to like no more than 5 minutes, right? So when you have a proof like this, work on it for 5 minutes. If you don't get it, watch the video the next day, review the Jamboard, and I think you will get it soon. Take care, guys. Bye.